So let's take a look at how to write an input adapter. So an input adapter would read from source and enqueue to StreamInsight. So if you look here, excuse me. So points to note, so this particular input adapter is actually deriving from a typed point input adapter. This is the type we would be creating. And if you notice here, there is we use something called ZMQ, subscribe socket. ZMQ is nothing but a 0MQ bus, similar to any other message bus, but for interprocess communications within your system, this is much faster and lighter. So this has been used for this illustration. So on receive from this particular socket, that is when a trade source or when an event source sends data to this particular subscriber, then this is the action that has to be taken. So you would be wondering where the actual connection happened. So on the start, so every adapter has a start method which will be called by your StreamInsight engine. So in the StreamInsight, we are subscribing to the address. So the address is coming from elsewhere. We'll discuss that in the next slide. So the address is coming as a parameter to it, and what happens is, we receive that event. If you notice here again, the event is received in its own type, which is a byte array, and then interpreted as a trade event type. And then we call a produce events, which is this. So this method takes the data from the on receive method, and what it does is it creates an insert event, and then puts the start date time, which is kind of a temporal data, and then keeps the payload as the trade event type. And what it does is it does an enqueue. So the enqueue actually pushes this data to StreamInsight engine. And now your adapters can be either typed or untyped. You can actually use a typed adapter if the event source only produces a single event type. That is, if it is with a typed adapter, the fields of the payload are known in advance. For example, in our case, we know how a trade event type would look like, so it's fairly easy. But in case the payload format is not known, then you could use an untyped adapter. So for example, if your event source is reading data from database tables, depending on the schema from which it's reading, the adapter could be untyped. Note that a single adapter instance at runtime can emit only one type, although it's untyped. So for example, if you bind one schema and if it starts generating one particular event type at the start, and it has to be the same until the end. Right. So in our case, the produce events is actually creating almost a similar event, but it may not be the case every time. Let's move on to how an output adapter would look like. Similar to input adapter, similar to enqueue function in input adapter, which pushes data into StreamInsight, we have a DQ API, which actually takes data away from StreamInsight, and it does a write to the target or strings. So this would be our DQ API. So this is where the DQ happens, and this is where the event from current StreamInsight will be placed, and then we convert that back to the format the event target would understand, and then we do a send right away. Again, the configuration to connect to this particular event target would be available through some mechanism, which again I'll be explaining in the next slide. So this is where so if you look at get CEP fields, what it does is it reads from SI specific format, and it just adds them as a list of strings so that it can be consumed by the target application. So the target application in this case does not understand the CEP type, but it does understand a list of strings, and so by ordinal position, it gets to know what kind of data is coming in. Again, similar to input adapters, this can be typed or untyped as well. So if you look here, we saw a typed point input adapter in the previous slide, and this one has dropped the typed word, and this is actually a plain untyped point output adapter. Let's see what or how the event model is. There are 3 event models: point, interval, and edge. So excuse me, the point model means that the event occurs only at a single point of time, so it's instantaneous, whereas interval model means it's valid for a given period of time. We have an edge model as well. Edge events are similar to interval events, but kind of a special case. They are valid for a specific period of time, all right, but the difference between interval and edge event is that for an edge event, only the starting point of time is known. The ending point is actually calculated by or within the application. An example that comes to my mind is web user session. Start of the user session happens when the request is received by the web server, but the end time is calculated based on certain heuristics within the web server. For example, was the session inactive for more than 20 minutes, then just close the session, or if the session is active only for or whatever, right? So so the end time is actually calculated by the server itself. For the above event models, you could actually build either a typed or untyped adapter. StreamInsight libraries provide the necessary base classes. So if you look here, we have for every event model, type, interval, edge, interval, or point, we have a set of input adapters and output adapters. And if you look at the nomenclature, it either uses a typed or it drops that word typed. So which means that it could be a typed adapter or it could be an untyped adapter. Excuse me. Then another important piece is the adapter factory classes. Now these are very important, as it's the only way for your StreamInsight server runtime to create and dispose the adapters. So it's also used to pass parameters at runtime. So if you have noticed in the previous input and output adapter slides, we would be using some binding configuration info to connect to sources and targets, and that's actually passed through this. So if you look here, we are creating a new instance of trade event point input adapter, which is what we had in the previous slide, and we are passing a bus config, and we are passing some addresses. So this address, if you look at the config info, this is actually passed as part of the trade adapter factory as such. So when this particular factory is created, or when the create method is called by the StreamInsight engine, we could potentially pass this config info and the event shape. So based on the event shape, whether it's a point or interval, you could decide which adapter to return. In this case, that has not been taken care. I think it's just returning a trade event point input adapter, whereas it should be like whether it's a point event, then return that adapter. Similarly, if you look at message bus output adapter factory, excuse me, so it uses the same or similar config info. So what it does is it creates a new message bus point output adapter and passes the config info here. So this config info is again passed when you bind it when you create this output adapter at the application level. Now that we have seen input adapters, output adapters, event models, and factories, let's pick them all. First, this is a simple console app written. So the first line says CP server equal to server.create of StreamInsight v2. So this particular name, what we have given, is actually the one that we should be using when. So this is the name which has been registered on the machine when we install StreamInsight, and StreamInsight will be creating an instance of this particular. So we'll be looking for this name to see it's available, and it'll throw an exception. And the next line says the create application of trade events. An application actually is kind of a scoping unit. Think of it like a namespace, although it's not. but I mean it's more like a scoping unit. All other entities that are created within this application that are created within this are actually created within this trade events CEP app. So this is where we create the input adapter config. So this is where we set up the bus information, the address to which it's connected to. So this is where the event source is actually sending the information to. And if you notice, the next line says create a new CEP stream. It gives a name of the stream, the type of the adapter factory to use. Notice that we are not creating the adapter directly, but we are passing the factory here, and we are also passing the input adapter config along with the event shape. So these two information will be passed when when the create method is actually called on the trade adapter factory, and this is then inherently passed to the adapter, and this is the only way you can pass the information. Let's say from config file or from the application to the adapter. The adapter will not know that in the design time, and hence this becomes important. The next query is actually a very simple query. Excuse me. So this is a query template. It's not really a query instance, but as the name suggests, it's just a query template. So what it does is it selects all the events in this input stream. So this input stream is nothing but every event that is coming in from the event source, right? So as the events gets published from the event source, every event comes here and then sits on this, or so there is no pattern really, right? But in real world, this won't be the scenario. So you would rather be using a query like this or a query template like this, wherein you're checking for where for each event, if the volume is greater than 1000 and if the price is less than 100, then select it and report it. So that could be one pattern that you would want to use. Or you could use a slightly complex pattern which says group these events based on on a window. So what it does is it actually creates a window. So every 5 seconds it groups them. So let's say if there are like 10 or 15 events that are coming within 5 seconds, all that are actually grouped underneath, and then there is a new group created, and sum of all the prices is calculated. What that means is every trade that's happening within these 5 seconds, calculate the sum of the price, and that is grouped on trade type. So it's like every trade type. Calculate the sum of the trades per trade type within 5 seconds. So we have tumbling window. So this is a simple window which groups the events every 5 seconds. And if you notice here, there is also a grouping function applied. So you could actually write some aggregate functions which can deal with the group data and then respond back to you on what you want to really do with that. So these are some examples of the patterns, but for brevity and simplicity, I have not used that. We'll go back to our illustration. And next, so after defining your input adapter and your so this is where you configure the input adapter. This is where you configure the template, and this is where we'll be saying how our message was config is. Again, this is config information, and then what we do is we bind them all to a query. So we take this template, create a query instance, which is this, and then we tell the StreamInsight server under which scope it has to be created, which is your trade event CP app, and you specify the output adapter factory. So the input adapter factory is actually a chain here. I mean, if you notice here, input stream is what is your query template is, right? So now since you are using this here, the input adapter has also already been chained. So finally what it is required is we have to configure the output adapter factory, which is what is done here, and then the config info of the target is set here. So this is where all the matched events will be going in, and this is just the event shape and the stream event order. So again, similar to input adapter. So similar to creating input adapter using a factory. If you notice here, even the output adapter is created using a factory, and the config is actually passed from this application through the factory. And all we have to do is do a dot start of the query, and StreamInsight will call the create method of this factory, pass this value, and then start listening to it, and then start running this pattern on that events which are received from the event, from the input adapter. Apply this pattern, and then as the patterns match, it will move it to the message bus output adapter. And here, as I said, there is no pattern. So what that means is it will be reporting all the events as they happen. So this is using the adapter model. Let's see. I don't really have. I just quickly created this. So let's see how an observable or enumerable model looks like. So if you notice here, we have an observable trade event source, which is implementing the iObservable. Excuse me. Just needs to. So we have seen IEnumerable enough. It's Microsoft's implementation of the iterator pattern. So in the world of interactive programming, the app actively pulls the data source by pulling the data using IEnumerable. So you might have used a for each within your collection to get or pull the data. But iObservable is a case of reactive programming. So that's when I mentioned the reactive extensions available for .NET. Here, what the app does is the app does a subscribe call to the data stream by calling the observable sequence, and from then on, it just reacts. So the app doesn't really go and do a for each, but it just reacts to what it has been subscribed for. There are two interfaces that are required for the push model. One is the iObservable, and the second one is the observable. So the observer will be listening to the observable. So if you notice here, so the observer calls a subscribe method of this particular observable class, which is your observable trade event source. And all the trade event source, what it does is it just does a subscriber.add, and as this observer is instance receives event, it will be pushing to all these observers. It is a typical observer model or observer pattern. So some intricacies are, so now that the trade event source is actually created as an observable, it will be interesting to note that the StreamInsight engine will act as your observer for this. So the query that you would have written will actually observe this. So StreamInsight would register as an observer, and then as the events happen, the data will get pushed from the observable to StreamInsight. StreamInsight gets those events and then applies it on their pattern, and then sends it makes the matched data available as observables again. So when it does that, there is an observing sync, which is an observer now. So this observing sync will actually act observe the StreamInsight. So if you notice the next example, so this is your main code where you create a new, so this is the line of interest. So you are actually, these two, I think we have seen this enough. So we actually create a new observable trade event source, and we create a point string, and then create an insert event from that point string, and we bind that as a query. And this is when actually this particular subscribe method is called. So what we have done is forget this bit. So we are doing all trade events dot to observe, right? So this all trade events is nothing but your input stream, and input stream is nothing but your observable events source to dot point stream, right? So this creates, so this query actually creates observable, a point stream from this observable, and this is applied over this query, and then this query is made as an observable here, and then this is actually pushed to the sink. So the sink would actually subscribe to this. So you can see that the subscription is called on the observer. In this case, is a sink. So events are passed from here to StreamInsight, and then from here it moves to the observing sink. The source or sink can be either an observable or an enumerable. So here the illustration is only on the observable. You can write a similar one for the enumerable as well. Now, I mean, together, both these provide an alternative model for receiving data from sources to StreamInsight engine or from StreamInsight engine to sink. It could use this model instead of adapters. In fact, so prior to 2.1, this model was only available for your hosted model and not for a remote instance. But starting 2.1, irrespective of whether your StreamInsight is a hosted model or remote, instance, you should be able to use both these models interchangeably. Moving on, let's quickly see some of the practical scenarios. So these are some of the scenarios where CEP is applied heavily. Real-time risk monitoring is one such example. CEP has been long used in used in financial markets. To understand the exposure to risk in real terms, firms continuously monitor market conditions and try to manage risks across traders and per desk. And as the risks, are surfaced, with the patterns that is being employed, you could actually forward it to further workflows. Pre-trade compliance is another one. It's not long used, but there could be some possibilities of using CEP around this. As the trades are about to happen, you could intercept and monitor them and apply a set of compliance rules. Depending upon the compliance adherence or the absence of it, you could forward to further workflow or allow the trade to happen as such. Real-time web analytics is another interesting area where you can employ CEP. As scores of clicks happen in the website across the world, you could continuously analyze the user behavior of the website. You could also aggregate these behaviors across your web farm nodes, and all of these happen at real time, so you don't have to log these data and then analyze later. So think of this, right? So let's say if you're using Google and if you're doing a London Olympics, so Google does its own or shows the results on its own, and it also lists some links. Now you can employ clickstream analysis to say how many people are really clicking on Google's links, or how many people are going below that area and clicking on some other, or scrolling and then clicking on some other, let's say London2012.com site. And so, you could vary your data position, or you could vary your the results being shown by Google to wherever you would want to be shown. Smart power grids are other classics. I think we all know power grids. Smart power grids actually balance the load or based on the demand. So you could potentially gather the consumer behavior information as they happen. So imagine this, right? So events are generated from every electricity meter, and that gets aggregated at every subzone, zone, or region level. And as you gather this information and analyze the demand, so you could probably pull the supply from somewhere and pass it on here, or you could do some matching on the fly. And all this is real time, so there is no real, you cannot get the data, put it on a database and start analyzing it and then say, hey, the supply is more or required more there. By that time the demand would have gone, right? So it has to be near real time, or at least near real time. Algorithmic trading is another classic scenario. The patterns in financial market data are configured in the CEP engine, and automated trading happens based on specific match patterns. There are several other scenarios that I could think of, reporting exceptions, operational intelligence, and business process monitoring. In financial industries, again, a lot of fraud detection happens through CEP. In IT, as such, you could probably detect intrusions, network intrusions, and application SLAs, monitor application SLAs as they happen, or in high volume data, like RFID reading, or Air traffic control is another classic example I can think of. Data coming from each flight near your airport. As they keep sending the information on how close or how far they are from the airport, this information has to be analyzed and seen if there are any two aircrafts that are coming dangerously close together. Again, it has to be real time or at least near real time. By the time, I don't think we have enough time to push to serialize this data into database and start analyzing and then respond back. So that's not going to happen, at least. Moving on. Sorry. So some further resources for tickling the brains. Reactive extensions. This is again a Microsoft link for a better understanding of iObservable and iObserver. And then StreamInsight 2.1 documentation as such. We have some good amount of glossaries. I think it's very important for us to read the glossary section first. It introduces a lot of new terms which we are usually unaware as a as an application developer who have been doing a lot of database applications. And then the third bullet is a PDF, again from Microsoft, I believe. It's an awesome resource that explains the query model and the window timelines and even the event model for that matter. And it's really good. It's a very concise PDF with all and good amount of explanations. Lastly, StreamInsight 101 samples. It's a beginner's paradise. So anyone who's interested in learning StreamInsight has to start here. It has fantastic samples and some pre-built adapters as well, which you can configure right away and then start working. So that's it from my side. I'm open to questions.